Welcome back to this lesson on supply chain sustainability. Upon completing this lesson, learners should be able to describe the sources of carbon emissions in supply chains and discuss the trade-offs involved in developing a supply chain network that is both environmentally and economically sustainable. In focusing on the environmental plank of sustainability, let's take a look at where carbon emissions are generated in the logistics element of the supply chain. This chart portrays the fact that on an aggregate basis, the transportation elements of logistics, being road freight, ocean freight, air freight, and rail freight movements, greatly dwarf the carbon emissions associated with logistics facilities. And this would seem to make sense when you consider the fact that many warehouses and distribution centers are relatively small producers of high emissions. For example, an ambient temperature distribution center or warehouse in a moderate climate area likely will have no heating or air conditioning, and it may rely primarily on racking and forklifts to move and store product. In this case, very little electricity or other utilities are being utilized, and therefore very little greenhouse gas emissions are being generated by the warehouse. Now, logistics facilities in a frozen environment obviously can be much more energy intense and have more emissions associated with them. However, frozen facilities tend to be much smaller in scale than ambient facilities. Of the different transportation modes, a couple things to think about. Over-the-road freight is more predominant for short-haul shipments, so there is a large predominance of freight moving at one point or another in the supply chain over the road. Also, road freight generally relies on carbon emission-intense, petroleum-based products to move goods. It's important to note that there are a number of initiatives underway to make over-the-road tractors less carbon emission intense by switching to fuels such as natural gas or even electricity. And for tractors with combustion engines, there are a number of initiatives such as the SmartWays initiative that have been established to encourage trucking companies to utilize efficient engines and adopt other techniques to reduce emissions. Ocean freight, while generally powered by oils, produces far less carbon emissions on a per unit basis than trucking. For example, one ship may hold the equivalent of tens of thousands of trailers, each individually being pulled by individual tractors. Rail freight is another high volume, low relative carbon emission producing mode on a per unit basis. Each of these modes have obvious benefits and considerations to be taken into consideration in terms of timeliness, required infrastructure for the location to handle that mode, etc. It is the task of supply chain professionals working in the strategic space to quantify, analyze, and creatively think through different alternatives that meet customer service requirements in addition to minimizing cost and minimizing greenhouse gas emissions. We have a question. Given your understanding of the elements of supply chain management and considering the discussion of logistics network carbon emissions on the previous page, what important element of the supply chain was not discussed? Do you think this element is typically a minor or major contributor to carbon emissions? Why or why not? There are a number of supply chain techniques, strategies, tactical moves, etc., that have varying impacts on carbon emissions. For example, offshore sourcing, as opposed to sourcing of goods from a neighboring state in the U.S., may increase logistics carbon emissions, as goods may have a road leg in the producing country, an ocean leg, and then a road leg at the domestic port, followed by rail transport or long-distance over-the-road transport, followed by potentially additional local over-the-road transport, as opposed to a short or medium-length truck or rail movement within a region of the country. Packaging and postponement decisions can have an impact on emissions in that varying finalization processes may lead to significantly different required volume moves. For example, if you envision a product such as a household printer associated with a desktop computer, the printer in its final form may have extensive volume within a case taken up by styrofoam to protect the printer. If the printers in their final state are shipped from overseas with all of the styrofoam and cube taken up for the individual printer, this may lead to excessive cube requiring excessive transportation volume, requiring additional greenhouse gas emissions, as opposed to an alternative approach where the various components of the finished printer could be shipped in bulk totes without the cube associated with styrofoam. In this case, totes full of, say, power cords or cartridges or the various other components of the printer could be shipped in bulk tote or bin quantities from various plants and then sent to a distribution center where final assembly capabilities could piece together the final printer and apply the styrofoam at that last stage in the process of the supply chain for the final delivery within region. This approach reduces the requirement of cube to be moved across the supply chain until the last moment. Other techniques for consideration include mode shifts, consistent with our discussion on the prior pages regarding the merits in terms of greenhouse gas emissions of one mode versus another. Another technique to consider, changing inventory policies, such that perhaps you hold more inventory in support of replenishment model that leverages full rail or full truckload quantities instead of partial truckload shipments. And another technique, looking at adjustments to manufacturing processes, again to help support more efficient transportation modes. Also, cooperative arrangements with partners in the supply chain, including perhaps sharing warehousing space and shared capacity on transportation. All of these different approaches can lead to greenhouse gas emissions reductions if balanced appropriately with the company's service policies and supply chain operating model. This exhibit is provided to depict the relative savings potential of considering different changes in operating processes versus the level of complexity of enacting those changes. And level of complexity is represented by the typical number of business processes or functions that would need to be engaged with or change their current operations in order to undertake the change. So on the far left-hand side bottom, we see changes in delivery service territories. Service territory changes may be when truck delivery routes are tweaked to be more efficient. Nothing else may change in the supply chain. And customers may not even notice the difference with a different truck or a different driver delivering orders. So the change is relatively easy to make and makes a moderate reduction in carbon emissions. Moving up in complexity are activities such as changing service policies to encourage customers to buy in larger quantities to help fill out trucks, which then saves emissions over sending partial truckload shipments. Moving further up the scale, undertaking policies that support shifting shipments to rail or intermodal modes of transport and the emissions saved by these moves. Then, when you start moving to techniques such as changing inventory strategies, the number of business processes that need to be involved in making changes starts to grow significantly. Manufacturing, procurement, warehousing, transportation, and perhaps even customer service and finance and accounting may be involved with changing inventory strategies, whether it is to add a number of stocking points or consolidate stocking points. The changes are more complex. However, they may support supply chain strategies that reduce greenhouse gas emissions to a greater degree. Finally, up at the top, we see supply chain network reconfiguration. This is where companies evaluate all aspects of their supply chain simultaneously, from source points through manufacturing of finished goods through placement of distribution centers, including transportation modes all along the way, inbound, outbound, and transfer. Analytically rigorous trade-off analysis of cost, service, and greenhouse gas emissions can be undertaken to find the right balance, and obviously any significant changes in the network configuration will require buy-in from a wide range of internal and external parties. Finally, we present a couple of comparative sets of statistics regarding two companies similar in size in terms of revenue, however coming from two separate distinct industries. food service distribution versus consumer electronics. Logistics carbon emissions footprint can be significantly different from industry to industry in terms of the source of the emissions and the aggregate level of emissions. In the food service distribution organization example, 73% of emissions are from inbound transportation, 26% from outbound, and 1% from the distribution centers. While with the consumer electronics company, 56% of the emissions were from outbound transportation, 8% from distribution centers, and 36% from inbound. One of the things I'm sometimes asked by companies is, how does my greenhouse gas emissions footprint compare to other companies? Is it good, bad, or indifferent? This is very difficult to address in that complex supply chain organizations have radically different supply chains in terms of number of plants, distribution centers, sourcing strategies, how they insource or outsource transportation, which modes are used, etc. And product characteristics certainly are quite different. So there's no consistent way to compare specific companies unless their operating models are extremely similar. In this lesson, we learned that within the logistics components of supply chain management, over-the-road transportation is the greatest source of carbon emissions. Supply chain strategies and tactics can have a large impact on carbon emissions, and it is difficult to compare logistics network carbon emissions across different industries. Thank you for joining us on this lesson, and we'll see you on the next lesson.